The race for AI dominance is moving faster than ever, and the stakes have never been higher. Datadog has just launched its new GPU monitoring tool worldwide to help organizations fight back against the massive, ballooning costs of AI computing. By providing a single, crystal-clear view into infrastructure health and workload performance, this platform is finally giving developers and machine learning engineers the power to identify idle resources and fix the bottlenecks that have been draining their budgets.
Never run out of battery again with the INIU portable charger, the slimmest 10,000 milliamp hour power bank that keeps your devices charged on the go. Stay powered up wherever you go. Click the link in the video description to shop now on Amazon.
But even with the right tools, you might be burning cash without realizing it, just like one global retailer recently discovered. An expert consultant revealed exactly how to double GPU efficiency without buying a single new card by implementing disaggregated inference. By splitting workloads into dedicated pools for prompt processing and token generation, they proved that monolithic setups are often hiding massive inefficiencies, and this strategy is already being adopted by giants like Perplexity and Meta. This trend of aggressive optimization is hitting the highest levels of the industry as SpaceX makes a bold, high-stakes pivot toward in-house GPU manufacturing. Detailed in their recent S1 filing, this project is tied to the massive Terafab initiative alongside Tesla and xAI, aiming to secure supply lines and fuel future growth. It is an incredibly ambitious move into a notoriously high-barrier industry, and now investors are watching closely to see if this massive capital expenditure will be a game-changing breakthrough or a potential financial hurdle. From cloud-scale monitoring to the future of chip manufacturing, the landscape of AI infrastructure is shifting beneath our feet. We are tracking every breakthrough, every billion-dollar investment, and every technical tweak that changes the game. Stay ahead of the curve and never miss a beat by hitting that subscribe button and turning on notifications right now. See you in the next one. Ever feel like your AI budget is disappearing into a black hole of expensive hardware you aren't even fully using? You're not alone. As companies scramble to build the next big thing in AI, they're quickly realizing that graphics processing units, or GPUs, are becoming an absolute money pit, often eating up 14% of total compute costs. Today, Datadog is stepping up to the plate with a global launch of their new GPU monitoring tool, and it might just be the lifesaver your infrastructure team has been begging for. Here is the reality of the situation. Many organizations have built a messy, fragmented patchwork of GPU resources. Because they lack a single source of truth, teams often resort to over-provisioning hardware just to be safe, which only drives costs higher. It is a classic burn money to avoid downtime strategy. Datadog's new solution flips the script by giving developers and ML engineers a unified dashboard that tracks everything from infrastructure health to specific workload performance. It's not just about knowing if a card is on or off. It's about understanding why your model training is dragging its feet or where you have idle resources that could be reallocated. Take Hyperbolic, for example. They've already integrated this into their multi-tenant infrastructure, and they're reporting that they can now diagnose a model latency spike and jump straight to the underlying GPU hardware metrics without ever leaving their dashboard. That kind of efficiency is exactly what differentiates a company that's just experimenting from one that's actually scaling. As Yanbing Li, Datadog's chief product officer, put it, this isn't just a technical hurdle anymore. It is a board-level conversation about economics and scalability. If you are serious about moving your AI projects from experimental labs into sustainable production systems, stop flying blind with your infrastructure costs. Head over to Datadog's portal to see if their new GPU monitoring can plug those leaks in your budget. After all, in the race to win at AI, the winners won't just be the ones with the most compute. They'll be the ones who know exactly how to spend it. What's your biggest bottleneck when it comes to AI scaling? Let me know in the comments below, and don't forget to hit that subscribe button for more tech breakdowns. Ever felt like you're burning money on hardware that's barely doing any work? I recently walked into a massive global retailer's data center, and the cloud finance team was genuinely sweating. They had scaled from 24 to 48 H100 GPUs, yet during the holidays, their system was still chugging. They asked the million-dollar question: do we need more GPUs, or is something else broken? So I did what any engineer worth their salt does. I stopped guessing and started profiling. What I found changed my entire perspective on AI infrastructure. See, LLM inference isn't just one job, it's two separate workloads masquerading as one. There's the prefill phase, where the model reads your prompt, which hits the compute cores at 92% utilization. Perfect. But that only lasts a blink of an eye. Then comes the decode phase, where the model generates tokens one by one. This is a massive memory bandwidth grind that leaves those expensive compute cores sitting idle, dropping utilization to a pathetic 30%. Because these phases were interleaved on the same chips, the dashboards showed an average of 55%. It looked fine on paper, but in reality, the hardware was spending 95% of its time starving for data while costing a fortune. Think about it. If you ran a database by provisioning for peak writes but then ignored it for reads, you'd be fired. Yet in the world of LLMs, we've been doing exactly that. The solution? Disaggregated inference. Instead of one pool, we split the cluster into two, one tuned for compute-heavy prompt processing and another for memory-heavy token generation. No new silicon, no massive hardware overhaul, just a smarter architectural split. When we ran the proof of concept, the results were staggering. Compute efficiency effectively doubled. We didn't just save $800,000 a year on cloud bills. We eliminated those annoying stutters where text generation would freeze because a new prompt hijacked the GPU. It turns out, tech giants like Perplexity, Meta, and Mistral have been doing this for a while, and the tools are already sitting there in the open-source stack like VLLM and SGLang. If you're still running monolithic inference, you're essentially leaving millions of dollars of compute capacity on the table. Stop obsessing over buying more cards and start looking at your instrumentation. Break down your utilization by phase, and I guarantee you'll see the waste. If this tech deep dive helped you rethink your infrastructure, hit that subscribe button for more engineering truth bombs. Are you over-provisioning your GPUs, or are you ready to split the stack? Ever felt like your cloud bill was growing faster than your actual AI projects? If you're in the world of machine learning, you know the struggle. GPUs are the golden ticket of modern tech, but they are incredibly expensive, and keeping them running efficiently is like trying to solve a puzzle in the dark. That is exactly why Datadog just dropped their brand new GPU monitoring tool, and it is a complete game changer for anyone trying to get a grip on their AI infrastructure costs. Here is the reality. GPU instances now gobble up about 14% of total compute costs. That is a massive chunk of the budget, and as companies scale, those numbers can spiral out of control. Most existing tools tell you if your hardware is on or off, but they don't tell you why your training runs are failing or why your inference is slowing down. That lack of visibility leads to a dangerous habit, over-provisioning. You buy way more hardware than you need just to play it safe, and your budget takes the hit. Datadog's new solution bridges this gap by linking your GPU fleet telemetry directly to the workloads actually using those resources. It gives developers and ops teams a unified view, so you aren't jumping between 5 different tabs to figure out where your money is going. As Datadog's CPO Yanbing Li pointed out, this has shifted from a technical chore to a board-level financial issue. When you can't track which business unit is burning through your GPU capacity, you can't budget effectively. Early adopters like Hyperbolic are already seeing the benefits. They are using the tool to manage complex, multi-tenant environments where they need to keep performance metrics isolated for different customers. They can now spot a latency spike and trace it back to the specific GPU bottleneck in seconds, not hours. Ultimately, this is about more than just monitoring hardware. It is about confidence. By knowing exactly what your existing fleet is capable of, you can make smarter decisions about when to scale and when to optimize. If you are tired of the guessing game in your AI stack, this is a tool worth checking out. What do you think? Is GPU cost management the biggest hurdle in your AI roadmap? Let me know in the comments below. And don't forget to hit subscribe for more updates on the tools shaping the future of tech. Remember, in the age of AI, efficiency isn't just a best practice, it's a competitive advantage. Imagine Elon Musk just turned the high-stakes world of aerospace into a silicon-fueled gamble. SpaceX is reportedly preparing for an IPO, but they've just dropped a bombshell in their S-1 filing. They want to build their own GPUs. Yes, you heard that right. The rocket company is trying to become a chip maker. Is this a genius masterstroke for vertical integration, or is it a financial black hole waiting to swallow their $1.75 trillion valuation? Let's break down the chaos. Look, the semiconductor industry isn't just difficult, it's arguably the most brutal business on the planet. Even NVIDIA, the undisputed king of AI, doesn't actually make their chips. They rely on TSMC. Yet SpaceX is betting on the Terafab project, a massive collaboration with Tesla and xAI to build an AI chip complex in Texas. Musk's goal: to solve the massive supply shortages threatening his autonomous vehicles, humanoid robots, and space data centers. He's even eyeing Intel's future 14A process technology as a potential backbone. But let's be real for a second. This is an incredibly risky pivot. SpaceX is currently a company that thrives on aerospace engineering, not nanometer-scale chip fabrication. Building a closed-loop chip ecosystem requires astronomical capital, and if they hit the same yield rate nightmares currently plaguing Intel's latest nodes, the burn rate could be catastrophic. Investors are looking at a $1.75 trillion valuation that already assumes perfection through 2030. If this GPU venture stalls or drags, that valuation isn't just going to shrink, it could evaporate. Are we witnessing the birth of a new industry giant, or is Musk spreading his resources too thin? I want to hear your take. Is this a visionary move or a classic case of overreach? Drop a comment below with your thoughts. Hit that like button if you're tracking the Musk empire, and make sure you're subscribed so you don't miss the next update. In a world of infinite ambition, only the execution separates the legacy from the lesson.